Optical isomerism, multiple choice questions. Question 1. Which pair of compounds does not form a race mix? Which pair of compounds does not form a race mixture when the compounds react? So race mixtures, example potassium cyanide with KCN, nucleophilic addition, example of nucleophilic addition mechanism, and you can either do it with KCN or HCN. Right, this is with HCl. That's with HCl, so it's definitely not going to be those. And which one does not form a race mixture? Well, it's going to be the symmetrical ketones. Yeah, because symmetrical ketones will not form a race mixture. And if you look here at D, that is completely symmetrical. Therefore, D is the correct answer. It will not form a race mixture as a symmetrical ketone. Question 2. Which compound does not show stereoisomerism? 1,2-dichloropropene. So what we'll look, if we look at this, like we can already say, because alkanes, no carbon-carbon double bond, right? So they're not going to, actually no. 1,2-dichloropropene, methane, ethane, propane. Assuming propene, so we need carbon-carbon double bond. A chloro on the first carbon and a chloro on the second carbon. And obviously we minus 2 hydrogens because of the carbon-carbon double bond. So will that show stereoisomerism? Yes, it will. Look at this carbon. 1, 2, 3, 4 different groups. So that will show stereoisomerism. 1,2-dichloropropane. Oh yeah, let's cross this out. Methane, ethane, propane. 1, 2, chloro on the first carbon, chloro on the second carbon. Fill in the hydrogens. Will that show stereoisomerism? Yes, it will. Look at this carbon, 4 different groups attached to a H group, a Cl group, a methyl group, and a CH2 Cl group. So that will show stereoisomerism. And obviously the question is asking was, which one does not show stereoisomerism? C13-dichloropropene, methane, ethane, propane. Obviously got propene. We got a chloro on the first carbon, a chloro on the third carbon, H, H, 1, 2, 3, H, 1, 2, 3, 4. I need 2 more hydrogens. I feel like I've done something wrong here in this case. Just trying to figure out what it is. So we've got CHCl, it doesn't have a chiral carbon. However, that doesn't mean it won't show stereoisomerism because the two groups attached. Oh, okay. Because the two groups attached to the first carbons are hydrogen Cl. The two groups attached to the second carbon are hydrogen, and obviously you got your CH CHCl group, and you've got your cis isomer and your trans isomer. So therefore, it's also not going to be that. But however, if you look at option D, methane, ethane, propane, chloro, chloro, hydrogen, 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 hydrogen. Carbon has one. That's not different, and these two are the same. So it's not a chiral carbon, and obviously because it's an alkane, and but obviously alkanes can only show stereoisomerism when they've got a chiral carbon. So in this case, it doesn't have a chiral carbon, therefore it's not going to show stereoisomerism. Whereas with 1,2-dichloropropane, yes, it's an alkane. However, because it had a chiral carbon, it still showed stereoisomerism. But in this case, no chiral carbon. It's also plus. It's also an alkane. No stereoisomerism. Question 3: which compound forms optically active compounds on reduction? So what I'm looking for, optically active compounds on reduction. So I'm looking for an unsymmetrical ketone. Unsymmetrical ketone. And A and B are not even ketones, they're just alkenes. So obviously on reduction, what are they going to reduce to? No. So I'm left with C and D. Now both of these are ketones. However, if you look at C, you can quite clearly see that obviously the carbonyl group's in the middle of the longest carbon chain, but you've got a CH3 here, a CH3 here, and a carbonyl group in the middle. So that tells me it is symmetrical, and if it is symmetrical, it's not going to form optically active compounds. Therefore, it can't be that, and therefore the answer must be D. And that is the end of the multiple choice questions.